Hi, today we want to look at the nature of the roots of a quadratic equation. There are three natures that we will look at. Number one is when the discriminant b squared minus 4ac is greater than 0. And at that time, we know that we have two distinct roots, two real and distinct roots. The roots are different. Now, I already made a video on this which is comprehensive and has a lot of examples. I am linking it up right now. Please go check it out. It's a prerequisite to this class. So, two real distinct roots. The second scenario is when b squared minus 4ac is equal to 0. And at that time, we have two roots that are real and the same. So the x-axis acts as a tangent to your curve. Two roots that are real and the same. The third scenario is when your curve floats on your graph. It floats, doesn't touch the x-axis. And for that case, we have b squared minus 4ac to be less than 0. So for this particular question, we are looking at two distinct roots, which means we have the first scenario. So we have to use b squared minus 4ac is greater than 0. And how do we use that? We are going to rewrite this in the form of ax squared plus bx plus c equals to 0. If we can do that, then we'll easily be able to pick our a, b, and c out of that equation and then use this inequality. Now let's rewrite that equation. I will first of all expand the right hand side as kx plus 3k. Next thing is to collect like terms. So I have x squared plus 1 minus k x, then minus 6 minus 3k equals to 0. Easily, I can pick out that a is 1 because the coefficient of x squared here is 1. B then is 1 minus k, and then c is minus 6 minus 3k. Okay, now I'm going to use this to continue solving. B squared says 1 minus k all squared minus 4 into 1, and then c, which is minus 6 minus 3k, should be greater than 0. Expanding this gives me 1 minus 2k plus k squared. Then distributing negative 4 gives me plus 24 plus 12k is greater than 0. Collecting like terms gives me x squared and plus 10k plus 25 is greater than 0. Can we factorize? Looks like it. We have k squared plus 5k plus 5k plus 25 is greater than 0. Now for the first two terms, k is common, so I factor that out. I have k plus 5. For the next two, 5 is common, so I factor that out. I also have k plus 5 is greater than 0, which means k plus 5 all squared is greater than 0. Now this is an inequality. To solve it, I always like to look at, you see, that graph, if I'm not mistaken, we go somewhere similar to this. And this would be negative 5. Okay. Now, what I want you to see is that this is my graph. I can cut it into two parts. All the parts that has all the x's that are less than minus 5, the part that has the x that is equal to minus 5, and all the parts that have all the x's that are greater than minus 5. I'm going to consider these three to solve this inequality. Now, for the solution of an inequality, please remember I also have a video on that one. I'm going to link it right up here. check it out. You will learn a lot. Now, k plus 5 and then k plus 5 squared. Those are the two scenarios we look at here. Okay, and I've told you that we are considering when k is less than minus 5. We are considering when k is equal to minus 5. And then we are considering when k is greater than minus 5. When k is less than minus 5, k could be minus 6. Minus 6 plus 5 will give us minus 1, which is negative. Minus 6 plus 5 is minus 1, but when we square it, it becomes positive. Okay? This is positive. So this definitely will contain the solution. That's for every k that is less than minus 5. Now let's take a look at when k is equal to 5. If k is equal to 5, this gives you 0, which is not negative. So 0 squared is also 0. So definitely this one does not satisfy what we are looking for. When k is greater than minus 5, k could be 0. 0 plus 5 is positive. 0 plus 5 squared will also be positive. So which means our answers for k, okay, lie for where k is less than negative 5 or where k is greater than negative 5. And this is the answer to our question. We will go to the next example. This one says find the value of k for which this has two equal roots. If the roots are equal, then we know that b squared minus 4ac is equal to 0. So b squared minus 4ac equals to 0. We only need then rewrite this in the form of ax squared plus bx plus c so that we can pick what our a, b, and c are. Now let's rewrite this. We have 4x squared minus 15x plus 20 equals to kx minus k. If I rearrange, I have 4x squared minus 15x minus kx plus 20 plus k equals to 0. I can rewrite that as 4x squared minus 15 plus k multiplying x plus 20 plus k. And from there I can pick that my a is 4, my b is negative 15, negative k, and then my c is 20 plus k. Next, I'm going to use this. Okay, b squared will be minus 15 minus k all squared minus 4 times a, which is 4, and then times c, which is 20 plus k. And that is equal to 0 as per this. If I expand this, I get 2 to 5 plus 30k plus k squared minus 320 minus 16k equals to 0. Collecting like terms and simplifying will give me k squared plus 14k minus 95 equals to 0. And then we factorize. And when we do that, factorizing then gives us k squared plus 19k minus 5k minus 95 equals to 0. Obviously, to understand this line, you must have known your factorization very well. Now, to factor out k here, I have k into k plus 19 minus 5 into k plus 19 equals to 0. And this gives me k to be 5 or minus 19, which are the values of k we are looking for. Now, one more example and then we close this class. For this one, it says find the values of k for which y equals to kx plus 1 is a tangent to that curve. If we remember, that is this scenario, okay? The discriminant, b squared minus 4ac, has to be equal to 0 for a line to be the tangent to this curve. Let me quickly paint what might be happening. So if you have this curve, and then there is a straight line that just passes through the curve at a particular point, then that straight line is a tangent to that curve. So what happens is that at that particular point where they meet, they will have the same value for x and y. So what we need to do is to equate this curve to this straight line so that we might be able to reduce it to a quadratic equation and then pick out our a, b, and c from it so that we might use this equation. I hope there's no confusion there. So how do we equate it? We simply pick 2x squared plus x plus 3, and then we say it's equal to kx plus 1, because that's essentially what happens when a curve meets a straight line. At the point where they meet, they are equal. So the curve is equal to kx plus 1 at a particular x. That's what we're trying to do. Okay, so we will rearrange this so that we have 2x squared plus 1 minus kx, then plus 2 equals to 0. What I've done is to collect like terms and then rearrange. Now from there we could pick that our a is 2, b is 1 minus k, and c is 2. So we put those into this expression, and then we will have 1 minus k all squared minus 4 times 2, then times c, which is 2, equals to 0. We simplify that to get 1 minus 2k plus k squared minus 16 equals to 0. If we simplify this, we should have k squared minus 2k minus 15 equals to 0. Now we can factorize this so that we have k squared minus 5k plus 3k minus 15 equals to 0. Now k is common, so I'm going to factor that out. Then I have k minus 5 left. Then plus 3 is also common for these two. Then I have k minus 5 equals to 0, which means k equals negative 3 or 5. Okay, so this brings us to the end of this lesson and the end of this video. There are many more examples that you could take. Don't hesitate to practice. Math needs a lot of practice. Also, if you have any question, please drop in the comments and I'll be very happy to answer your questions. See you next time. Bye.